Hello there. My name is Michael Tawonga Kamanga. I'm here to teach you chemistry, that is chemistry from 1. And in today's lesson, we'll look at the electron structure, which is also known as the electron configuration. And in today's lesson, the success criteria is by the end of this lesson or chapter, you should be able to describe the arrangement of electrons in shells of an atom. Describe the arrangement of electrons in shells of an atom. Okay, so previously we looked at the atomic structure. So as our prerequisite knowledge, the atomic structure, remember that the atomic structure is a fundamental concept in chemistry and physics that describes the arrangement of the subatomic particles within an atom. And as a matter of reminding ourselves, here are some basic components of an atom. We have the nucleus, which is the dense central core of an atom, which contains the protons and the neutrons. The protons, remember, they have a positively charged, they are positively charged rather, and even the number of protons defines the atomic number, and it also determines the element. And the neutrons, they are neutral in nature, bearing a zero charge, they have no charge. And together with protons, they contribute to the atomic mass of an atom. Then for the electrons, they are negatively charged particles. They always orbit the nucleus in various energy levels or electron shells. And in terms of locality, remember the electrons that are found outside of the nucleus, because the nucleus is the center of an atom. And inside the nucleus, it is where we find the protons and the neutrons. And understanding these basics of atomic structure will help us to comprehend how atoms interact, how they form bonds, and how they participate in chemical reactions. And be reminded that out of the 3 subatomic particles, the electrons, they're the ones which are involved in chemical reactions and chemical bonding. Now, we should begin by defining what is an electron configuration or electron structure. Remember, the electrons are the ones which are found outside of the nucleus. They are found in shells. They are found in orbits. So with respect to these electrons, electron configuration is defined as the arrangement of electrons in the orbitals of an atom or molecule. In the orbitals, or we call them shells or energy levels. But if we go deeper, you understand that they are not shells or energy levels, but they are orbitals. Now, this configuration describes the distribution of electrons among the various atomic orbitals. It gives a clear description on how the number of electrons, the given electrons, they are distributed in various atomic orbitals. So this electron configuration It is not only telling you the number of electrons within an atom, but also it is telling you how these electrons are distributed or arranged in energy levels or shells or orbitals. So understanding electron configuration is very critical. It is very essential for explaining the chemical behavior and properties of elements. This electron configuration will help us to justify the chemical behavior, to explain the chemical behavior and the properties of elements. Now, in chemistry, energy levels are, in particular, they refer to the fixed distances from the nucleus of an atom where electrons can exist. In other words, in other language, these energy levels, they are regions of a higher probability, regions where you are most likely to find these electrons. So these levels are quantized, meaning electrons can occupy specific energy levels and not the spaces in between. No, they will always occupy a specific energy level and not spaces. To be quantized, each energy level is associated with a certain amount of energy. Remember, energy levels are also known as shells. Understanding energy levels is very crucial for explaining the behavior of electrons in atoms and how they interact with each other during chemical reactions. So in electron configuration, out of the three subatomic particles, we are only concentrating on electrons. Why? Because they're the ones which do take part in chemical reactions and they're the ones which are found outside of the nucleus. So each energy level has its own definite amount of energy. They have a certain amount of energy which is associated to them. So the energy level near the nucleus, it has the lowest energy compared to all the others. So this energy level, it is referred to as the penultimate or the innermost energy level or the innermost shell. It is very close to the nucleus and it has the lowest energy compared to other energy levels. So the further an energy level is from the nucleus, the more the energy it has. So as you are moving from the nucleus, as you are increasing the radius, you are also increasing the energy associated to a specific energy level. So the one which is close to the nucleus will have lower energy, while the one which is at a distance, which is further from the nucleus, it will have high energy associated to it. So the electrons in a given energy level also possess the same amount of energy as the level. Remember, the electrons are found in these energy levels. So each energy level has its own amount of energy. And the electrons occupying that energy level, they will also have the same amount of energy as compared to the energy of the shell. And if the energy of an electron is increased, the electron will jump to the next energy level. In other words, it becomes excited. So it will jump to the next energy level. And energy levels, they help explain the electronic structure of atoms and their chemical behavior, providing a basis for predicting how different elements will react and interact. In a nutshell, the energy levels will tell you how many electrons are in there. And those electrons, remember, they are always involved in chemical reactions. So electron configuration is very, very important. Electron structure is very, very important. Reaching this far, can you define what electron configuration is? I believe you have defined it as the arrangement of electrons in energy levels. Now, this table is giving us a summary on the possible number of electrons held by a given energy level. In other words, for a given energy level, how many electrons can be occupied in that energy level for that particular energy level to be full. So we'll have energy level and then the possible number of electrons held by the level. The energy level number 1 will always have a maximum of 2 electrons. Remember, energy level 1 is the one which is close to the nucleus. So the innermost energy level, which is close to the nucleus, will be fully filled by 2 electrons. While energy level number 2 will occupy a maximum number of 8 electrons. Energy level number 3 will occupy a maximum number of 8 electrons. Energy level number 4 will occupy a maximum number of 18 electrons. Energy level number 1, 2. Energy level number 2, 8. Energy level number 3, 8. Energy level number 4, 18. Okay. For example, let us look at the electron configuration of calcium. The electron configuration of calcium. Calcium, in total, it has a maximum of 20 electrons. Calcium has a total number of 20 electrons. Now, remember, on the previous slide, we saw that in energy level number 1, energy level number 1 will occupy a maximum number of 2 electrons. So, out of the 20 electrons, our first energy level, this is our first energy level because it is the innermost. It is the one which is close to the nucleus. This is the nucleus. This is our energy level number 1. And as you can see, how many electrons are in this energy level number 1? This sphere, this circle. As you can see, we have electron number 1, electron number 2. So in total, we have 2 electrons. So from 20, if we subtract 2 electrons, we are remaining with 18 electrons. Remember, we want to arrange all the electrons in the energy levels. Okay, let us go to the next energy level. This energy level, it is energy level number 2. Energy level number 2. So, we said in energy level number 2, how many electrons will fill energy level number 2? The answer is 8. So 8 electrons will be filled in energy level number 2. So as you can see in this energy level number 2, we have a maximum number of 1, 2, 3, 4, 5, 6, 7, 8. A maximum number of 8 electrons. A maximum number of 8 electrons. So from 18, we are remaining with 10 electrons. Remember, we have assigned 2 electrons in energy level number 1, 8 electrons in energy level number 2. What about in energy level number 3? From our last slide, energy level number 3 will occupy a maximum of how many electrons? I believe you have said 8. Yes, you are correct. The answer is indeed 8. So 8 electrons in energy level number 3. So we have 1, 2, 3, 4. Okay, sorry. 1, 2, 3, 4. Supposed to be 5, 6, 7, 8. So there's an error here. You have to correct here. There's an error. Supposed to be 2. In total, we're supposed to have 80 electrons. So it's 1, 2, 3, 4, 5, 6, then 7, 8. 8 electrons. So from 10, we are remaining with how many electrons? 2 electrons. So this energy level is full. Let us go to the next energy level, which is the energy level number 4. Energy level number 4. So in energy level number 4, we said we are supposed to have a maximum number of 18 electrons. But we are having 2 electrons remaining. What are we supposed to do? No problem. We are going to assign those remaining 2 electrons to energy level number 4. So in energy level number 4, this one, energy level number 4, we have assigned a maximum number of 1, 2 electrons. We have assigned 2 electrons. So in total, we have 2 in the first, 8 in the second, 8 in the third, then 2 in the last shell. So our energy level is 2882. In total, we are having a maximum number of 20 electrons. So here it's supposed to be 2882, and here add 1 electron. Good. Then chlorine, the electron configuration of chlorine. The electron configuration of chlorine. Okay, chlorine, it has a maximum number of 17. A maximum number of 17 electrons. So, can you go through the diagram? Analyze it. Go through the diagram and analyze it. So the 17 electrons, 2 electrons, 1, 2 in the first shell, then 8 electrons in the next shell, 1, 2, 3, 4, 5, 6, 7, 8, good. So 2 plus 8 is 10. From 17, we are remaining with 7 electrons. So in the last shell, 1, 2, 3, 4, 5, 6, 7. We have exhausted all the 17 electrons. So we have assigned the electrons in energy levels. Now, we can have a general overview of electron configuration of the first 20 elements. The electron configuration of the first 20 elements. So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So these are the first 20 elements. For hydrogen, we have one electron. So this one electron will be filled in shell number 1, the innermost shell. Then helium, it has a maximum number of 2 electrons. So the 2 electrons in the first shell. Then fast forward, let us go to oxygen. Oxygen, it has a total number of 8 electrons. So the 2 electrons are filled in the first shell. Then the remaining 6 electrons are filled in the last shell. That is why for oxygen it has 2 period 6. 2 electrons in the first shell. 6 electrons in the second shell. So in total, 8 electrons. What about number of shells? How many are they? Yes, 2. There are 2. Then argon. Argon in total it has a maximum number of 18 electrons. So the first 2 electrons in the first shell. Then in the second shell, 8 electrons. Then in the last shell, we have a maximum number of 8 electrons. So in total, how many electrons? The electrons are 18. How many shells? 3 shells. So we have 2, the first shell, 2 electrons. Second shell, 8 electrons. Then in third shell, 8 electrons. So the electron configuration is 2, period 8, period 8. So as you can see, electron configuration will also tell you the number of shells. Not only that, it will also tell you the number of electrons. And on top of that, it will tell you the number of electrons in a given shell. So for instance, for argon, you will know that in the first shell you have 2 electrons. And in the last shell, you have 8 electrons. And this information is very, very helpful. It is very, very helpful. Knowing the number of electrons, knowing the number of shells, knowing the electron configuration is very, very important. Okay, what is the significance of electron configuration? So in summary, here are some of the key reasons why electron configuration is important. First and foremost, in chemical bonding, because the electron configuration will tell you the valence electrons. And these valence electrons, the electrons which are found in the valence shell. The valence shell is the outermost shell. So it will tell you the number of electrons in the outermost shell. Or the valence electrons, you can define them as the electrons which are found in the outermost shell. So electron configuration will help us to determine the number of valence electrons, which are the outermost electrons involved in chemical bonding. Not only that, but it will also tell us the types of bonds, the same electron configuration, whether the bonding type is ionic, covalent, or metallic. The same electron configuration will also tell you the molecular geometry. That is how electrons, the arrangement of electrons influences the geometry of molecules, affecting their shape and properties as well. The same electron configuration will also assist us to know the trends of the periodic table. That is the element properties, their groups and periods. On element properties, that is the electron configuration will explain the placement of elements in the periodic table, helping predict properties. And which are these properties? Reactivity, electronegativity, and ionization energy. The same electron configuration will assist us to know the groups and periods. Okay? The groups and periods, because the electron configuration tells us about the number of electrons. It tells us about the number of shells. So this information is very, very important. The same electron configuration will tell us about reactivity and stability. It will tell us if an atom is stable, if an element is stable. That is, if it is having fully filled shells. It will also tell us about reactivity, how reactive an element is, basing on the number of electrons in shells. It will also tell us about magnetic properties, that is paramagnetism and dimagnetism. That is the paramagnetic substances, they're the ones which are having unpaired electrons and they are attracted to magnetic fields. While diamagnetic substances, they have paired electrons are slightly repelled by magnetic fields. So all this information is because of the electron configuration. The same electron configuration will tell us about spectroscopy and light emission. That is the emission spectra, absorption and emission in line with electrons, how electrons are arranged. So this tells us about spectroscopy and the light emission. So this information, you will discuss it further in the physics and in Form 3 and Form 4 chemistry as well. The same electron configuration will tell us about chemical reactions. You may recall that electrons are the ones which are involved in chemical reactions. So by knowing the number of electrons and how these electrons are arranged, you can know the reaction mechanism and you can also predict products which are formed in a chemical reaction. The same electron configuration will tell us about quantum numbers and atomic theory. So by understanding electron configuration, this is essential for predicting and explaining the chemical and physical properties of elements, guiding the study and application of chemistry in fields ranging from materials science to biochemistry. Well, this marks the end. Now that we have looked at the electron configuration, we have looked at how electrons are arranged in a given orbitals or shells. Let us go through the following activity. Feel free to ask more questions in the comment section, and also you can also give the answers in the comment section in regard to the activity, and you can compare your answers with my suggested answers as well. So the first question is what is the electron configuration of hydrogen? Second question, write the electron configuration for oxygen. Third question, what is the electron configuration of neon? Question number 4, determine the electron configuration for chlorine. So make sure you go through these 4 questions and provide your answers in the comment section. So for any inquiries, for any questions, there's a WhatsApp number there and an email as well. Thank you for your time and thank you for listening. See you in the next lesson.